we want to build a better, infrastructure for that. So we kind of see that, I call it the common denominator. There's that infrastructure piece that everybody's going to have to work with. If it's elastic scaling, if it's data plane, control plane, security, there's pieces that everybody have to understand. And that infrastructure is then used for different things. Enterprise want to use it for workload offloading. Service providers maybe want to use it for the virtual EPC, for the new LTE deployments or virtual CPEs. So there's a lot of applications for it, but it all boils down to that infrastructure. So this is my tie into SDN and NFV to answer your scale question in a moment. But it's proliferating throughout the network. Initially the NFV was kind of the enterprise firewall and virtualizing some of those elements, but it's now, we have the core being virtualized for NFV elements. We have all the way down to the residential to the edge. So it's throughout the entire network. So when they're talking about scale, they're talking about hundreds of thousands of virtual machines and VNFs being deployed. We were asked by two companies, one a cloud provider and one a network equipment manufacturer that's building out a system. Can you help us scale to test 500,000 virtual network interfaces, virtual machines? So we said, wow, one, yeah, we can. And two, we had to go and design a system. So we designed a system that, I'll skip through this a little bit because we're going to run short on time, to do on-demand scale testing. So we call it our hyperscale solution. So what we have for NFV infrastructure or just VM infrastructures, there's a need to test from a couple of VMs just to make sure everything works, all the way up to 1,000 to 2,000 to 10,000 virtual machines. One, to make sure that they were deployed correctly on the virtual infrastructure, to make sure the fabric has the right tunnels association, because all these systems now use a controller, some type of SDN controller, to go and configure the network, configure the VXLAN tunnels, configure the underlay and overlay network, so everything is connected. So it's not just understanding the scale from the virtual network side, but it's making sure everything is actually connected how they expect it when they're dealing with this dynamic change and dynamic scale.
Can I ask you a quick question then?
Yeah.
You're about destroying all of this when you're finished with it.
Yes.
So how do you know that your test represents what would actually get booted up in the real world?
Because
it could be on completely different physical servers or other components.
Oh, so no, so the idea here is the companies that are asking is to run this on their deployed network first. Yeah. So it's kind of on demand. And we get instructions, our API gets instructions from the controller. That same controller that's going to configure the real VMs. So we effectively look like real VMs. So they'll run a quick deployment test, launch our VMs, we'll make sure everything is connected and tear it down, and then they'll go launch their other ones. They'll sign the same MACs, the same VXLAN tunnel IDs, and configuration.
That doesn't mean it'll always be instanced on exactly the same infrastructure. If you had a few hundred physical hosts, you might run it on, it might turn out that it deploys them in half of them. It might not deploy them across the whole lot.
Right. So
how do you make sure that you're testing every part of that infrastructure evenly? So
the companies that asked us for that example, they are actually buying enough servers to vet that out because their customers have the same exact question. How do you prove that it works? Okay, I'll show you with a quarter density. No, I want to see with your fabric switch and your servers and your controller, everything working together with the policies enforced. So the way this works, I'm going to show this little kind of walkthrough, and I have a recorded demo because it takes a little long to spin up thousands and thousands of VMs on the infrastructure. But we have what we call our hyperscale user interface. Again, you'll see in the video that it follows the same look and feel as the traffic center and others. But what we have is the concept of pods. So we've recreated our system. We have very small agents that can be deployed at higher scale. So we come in, we call it the virtual deployment service. So you can run on OpenStack, you can run on VMware, you can run on Docker or some container service, and you can mix and match and select which kind of cloud infrastructure you want to run this in. I say go, and I want to go and deploy my virtual machines. So you can scale up however many it is that you need. If it's 10, 20, 100,000, you basically define these pods and say launch. And each pod can be thousands of VMs, each VM with multiple virtual NICs, or whatever the configuration from the customer would be. Scale it up, and then after we launch it, We then take the test parameters and we synchronize everything running together. So as I go, we have these clients running that manage all that data, if it's containers or OpenStack. So we collect it so it's not all traversing the entire network all the time. We collect the core results and pump that back up into the infrastructure, that user interface that summarizes the whole test running. And then when we run that traffic, it then stresses the system. You have the ability to do UDP, TCP, whatever traffic's necessary from what the customer is trying to do. So if you have policies in place for certain TCP ports to be forwarded to different areas, we can track that and measure that. So the test itself.
What's the biggest scale test, just for interest, that this is actually run? You're talking about...
Right. So to his point, I didn't get his name, but so the test that we have right now is 4,000 virtual machines running all together. The customers that we're working with are procuring more servers to scale that out. They wanted a proof of concept. We have a carrier that's asked for 20,000. So that is a proof of concept that we're running in December. So 20,000 virtual machines all running. That one is a OpenStack environment. And we've been asked to do a container version as well.
So here's a question for you. Traditionally, and I assume this will be less, but traditionally, your testing solution and your major brand X competitor for the physical network have been what I'll describe as eye-wateringly expensive on a per port basis. I mean, like scary expensive to do testing, right? How does this, I guess, compare? Obviously, it's going to be a lot cheaper per port because it's not really the same methodology. I mean, what are we looking at as far as a range of sort of if I want to do testing against 4,000 versus 20,000?
Yeah, so that'll range because a lot of it's customized. So it's not just a product because everything's customized. I want you to work in this environment. So I mean, it can range from tens of thousands of dollars depending on the scale to hundreds of thousands. And kind of tying back into that, the way we sell our big box equipment, you buy it forever. And that's why it's expensive. I buy a 100 gig port, it costs a lot. With what we're trying to do with Traffic Center is get started for a couple $1,000s to do 10 gigs of traffic, per user, per active test, and get into that consumption-based model that's more receptive to where we see the market going. So we're trying to alleviate that big hurdle of, hey, I don't need to test because it's too expensive, to the, hey, I can test now because I can afford it and I can make a better network. So the way this works is very simple UI. You can define your pods, name your pods, and come in and these pods are defined by a file. This one has, I think, a few hundred virtual machines as part of that pod. You would divvy up those pods based off of the scale that you need for those servers. So it's just a way for us to manage the test a little bit better. And if you want to, you can start and kill these pods. The customers that we worked with so far are less concerned of the type of traffic or the detailed traffic. They just want to be able to say, hey, I don't need gigs of performance. I just want to run some traffic to validate everything is connected properly. And that I don't have leakage, I don't have dead.
So can I say, for example, on my fabric, what would happen if I unplug this particular port? Would it reconverge correctly or not? Can I do that?
Yes.
Okay.
So what
good answer, by the way.
Yeah. So what you're going to see in this network, this example, so we're going to start this test, and what you're going to see is that the received amount is greater than the transmitted amount, and so they're flooding streams. So VMs, and it's not in promiscuous mode, the virtual switches. So these virtual machines are getting more traffic than they should be. And then you can then dig down deeper. This is the high level, and you can zoom in and get the details of, hey, why is it flooding? Or if you have the convergence and failover redundancy baked in, and you do unplug something, and all of a sudden you get a dead flow, that means it did not converge. And we'll tell you which virtual machine, which virtual NIC and IP MAC did not converge. So you'll be able to run the test. We have all of our kind of health indicators. For this particular example, we have just one, which is drop frames, but we can expose as much as we want depending on the customer use case. And you can see here that we have more traffic, more received than the actual transmitted. And this was a simple pair, not a full mesh or backbone. So it's just a way to scale up. I can spin it up. I can run my test at thousands of VMs, on containers, on OpenStack, on VMware, and just make sure everything is connected properly. And where we see this working is, hey, I want to upgrade my OpenStack to the next release, or I have a new container version. I can tear everything down, spin everything back up, and just run a quick test, just to get that assurance that things are going to work prior to rolling out my real services.